Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at complex conditions in C++, by which I mean conditions that are made up of more than one clause. So let's put a multi-line comment here. We can put /* and finish it in // and actually Eclipse helpfully puts in asterisks for me here if I hit return, which are not part of the comment notation. You only need /* and // to start and end a multi-line comment, but these stars just kind of make it look nicer. So so far we've seen equals equals, which is the equality test operator. We've seen not equals, so that's not equals. We've seen less than, so this is less than, and we've seen greater than, greater than. Now we can combine these conditions into more complicated clauses. So let's create a value here. Let's say int value 1 equals 7, and we'll have another one, int value 2 equals 4. So we've seen that you can do things like if value 1 is less than 8, then cout, let's call this condition 1, and we'll put here condition 1, let's say condition 1 true, endler, and we'll have an else as well, so else we'll say condition 1 is false, condition 1 false. So that's less than. If we run this, then we find that value 1 is less than 8. So this is true. If we put greater than 8, then we get false. Now a couple of other conditions actually that are worth mentioning are this. So there's less than and equal to. So less than or equal to, and greater than or equal to, so greater than or equal to. Sometimes it can be easy for beginners to confuse which way around these symbols go, but if you look at it, equals and greater than, that would kind of look like a sort of arrow, and it's not an arrow, it's this. So this way around looks like something other than what it is, but this way around actually looks, that's actually correct. This is less than or equal to. Well, I suppose it looks like an arrow pointing to the left, but anyway, maybe that will help you to remember. So the less than or greater than has to go first, and the equal to later. And what that means is if we say value is greater than or equal to, value 1 is greater than or equal to 7, this will be true if value is greater than 7 or it's equal to 7. So in either of the cases it's true. And in this case, value 1 is equal to 7. So this evaluates as true. It's also true that if we say value 1 is greater than or equal to 8, that's false. So let's run this. It's not greater than 8 and it's not equal to 8. If we say greater than or equal to 5, that's true. It's not equal to 5, but it is greater than 5. So these are very, very commonly used in C++. Now we can combine all the conditions that we've seen so far into more complicated clauses. Let's take another example here, and we'll call this condition 2. And I'm going to format that with the auto format there. So we can say, for example, if value 1 is equal to 7 and value 2 is equal to 4. What is this? This is the AND operator. We need two ampersands here to represent AND, because a single ampersand represents the bitwise AND operator, which we're going to see later on in this course. But this means a logical and what it means is that this entire condition is going to be true only if this is true, the first clause, and this is true, the the second clause, they've both got to be true to make this equal to true. So if we make one of them false, for example, we could say and value 2 is less than 3, which it isn't, it's 4. If we run this, then we find that this is false. So now the first clause here, that's true, value 1 is equal to 7, but value 2 is less than 3, and that's false. And so because we haven't got one is true and the other is true as well, then the whole thing is false. The way C++ reads this is it reads complex conditions from left to right. So it's first going to evaluate this, and then if it's necessary, and it is necessary for this and, it will then evaluate the next condition here. We've also got a logical OR, so let's copy this and take a look at OR. We'll call this condition 3. And we're going to change the AND here to 2 bars like that, and this is OR. And again, a single bar means the bitwise OR, which we'll also look at later in this course. So you need a double bar like that for the logical OR. Now what this does is it says the entire condition is true if either this is true or this is true. So either one of them being true makes the condition true. Now here we see that value 1 is equal to 7. So that's true. Value 2 is less than 3. That's false. Value 2 is 4. But the entire condition is true because just one of these is true. So we're saying if this is true or this is true, either of them being true will make the entire condition true. So if we run this, we find that the condition is true. Now again, C++ will scan this from left to right. So it's going to say, is this true? Value 1 equals 7. Yes, it is. So it actually won't even bother doing this because there's no need to. It can already see just from this that the entire condition must be true because either one of these being true would make the whole condition true. If the first one is true, it doesn't have to evaluate the second bit. If this was false, it would have to say, well, okay, the first one's false, but we're doing an OR here. So the second one could be true, and that would make the whole thing true. So in that case, it has to evaluate the second one as well. But if it evaluates the first one, and that's enough to make the whole condition true, it won't even bother checking this second bit. And sometimes you actually find code, like a subroutine call, as we'll see later on, in this second bit, that is deliberately not done if the first bit is true in an OR clause like this. But that's a pretty confusing way of writing code, which I wouldn't recommend at all. Now we can build up even more complicated conditions, and it's very easy to get in a mess with conditions. One little thing is we can say if value, let's say value 2 is not equal to 8, then let's maybe copy this stuff here, and I'm going to put condition 4 here. It's really important to name your variables and your name all your variables and subroutines, which we'll see later, with a name that illustrates what they actually do. And here, because I'm writing a demo program, because there's no real purpose behind this other than to demonstrate this, I'm having to call them value. But you shouldn't do that in your programs. Try to give them a meaningful name. So here we're saying if value is not equal to 8, then we'll execute this. If the condition's true, value is not equal to 8, that's true, then we'll do this. Otherwise we'll do this. So this works, and if we look at it, we say, well, value 2 is not equal to 8, that is true. Value 2 is actually 4, so we're going to do this. And if we run this now, we find that condition 4 is true. But this is a little bit more confusing than if we made this equals equals and just swap these around. So instead of doing a test for non-equality, we could do a test for equality with equals equals and just swap those two bits of code around, and that would be a bit easier to read. So it's better to do that. Try not to use not equals in your conditions unless you need to, or unless you really feel that makes the code easier to read somehow. Now you can make this even worse because we can combine multiple conditions. Let's say if value 1 is not equal to 8, and value 2 is equal to, let's say value 1 is equal to 7, which it is, or value 1 is less than 10, which is true. What's this going to do? It's starting to be quite hard to understand. You can't immediately look at this unless you're really good and you've had lots of practice and say what it does. And even for me, I mean, I couldn't immediately look at this in a program and think what it does, especially not bearing in mind that these are usually going to be values that are calculated in your program, and they're usually not just going to be what we call hard-coded literal values here. We say hard-coded, meaning we've actually put it in the program, put the value in the program, hard-coded it. Usually these are going to be the results of calculations, and that means that this can be quite hard to understand. So if we look at it, we're saying if value 2 is not equal to 8, let's just check this little warning sign here. That's a good suggestion. It says suggested parenthesis around expression. So we'll take a look at that in a second. But we're saying if value 2 is not equal to 8 and value 1 is equal to 7, is that true or false? Is value 2 not equal to 8? Yes, it is. It's equal to 4, so that bit's true. Is value 1 equal to 7? Yes, it is, so it's true. So this whole bit is true. And we're saying that or value 1 is less than 10, which actually is also true in this case. Let's make the AND condition false. So let's say if value 2 is not equal to 8, okay, that's true, and value 1 equals 10. Now this bit's false, but this bit's true. And remember, we're going to evaluate these from left to right. So we're going to first do this. C++ is going to take a look at this. It's going to say, is value 2 not equal to 8? That is true. It's 4. So then it actually doesn't need to check this because the first... Oh yeah, it doesn't need to check it because in an AND, what am I saying? You see, I'm already getting confused myself. Yeah, so in an AND, you've got to evaluate both bits of the expression to determine if the whole AND is true. So it says, is value 2 not equal to 8? Yes, that's true. But we have to check the other bit as well. Is value 1 equal to 10? No, it's not. So this whole condition is false. But then it says this whole thing is going to be true if either this bit or this bit is true. Is value 1 less than 10? Yes, it is. So the whole condition is true. Reading it from left to right, bit by bit. When we run it, we find that it's true. But this is confusing. It's difficult to read. It's unpleasant. We've got a not equals in there, which makes it even more unpleasant. And we're combining all these conditionals, and we're relying on them being evaluated in a certain order for it to come out right. So when you have conditions like this, it's best not to leave them in your program. Try to simplify them. And there are two major things that we can do to simplify these conditions. One little thing would be to try to see if you can write this without not equals. That would already be a little bit better. But then we can put parentheses around the individual clauses. So let's at least put parentheses, I guess you say, around this. Because we can make it clear that that's got to be evaluated before, that's got to be evaluated as a block before we go on to do this. So if we run this now, it runs the same as before, and it's true, and the warning sign has gone away. The warning was suggesting that I put these in, and it's a bit clearer to read. Now, another thing you can do that makes it even clearer is if you really have to have a complicated condition like this, you can at least store the conditions in Boolean variables. So supposing I say bool, let's call it condition 1 equals, and I can say condition 1 is this bit here. Let's copy this. So this is relatively easy to understand. We've got the not equals in there. So this is just an assignment operator. We're going to evaluate this and store it in this condition. When a program reaches this point, it's going to evaluate this condition and store it in here as true or false, because remember, bool stores true or false. So let's put brackets around it to make it maybe even a bit clearer. We can put brackets in kind of judiciously, however we feel. Maybe we feel that this looks a bit nicer, for example. That's fine. So we're going to say if value 2 is not equal to 8, which we can see is true, and value 1 is equal to 10, which is false, so the whole condition is false. And we could actually output that here. Let's output condition 1 to see that it is false. And it's a really, really good habit to get into the practice of, as you go through your program, if you calculate values or you get user input, output them with a cout like this. If it's user input, surround it with single quotes, as I showed you earlier, to make doubly sure that the values you've calculated in your program are what you expect, and do that before you go on to write the next bit of your program. It's really bad just to build up a really complicated program, not checking anything, not stopping compiling and checking values as you gradually build up the code. And then when you get to the end, you find it doesn't work and you've got a big task in debugging it. It's much better to build up a program step by step, checking that the values are what you expect as you go along, and then you can save yourself a big headache later on. We can then say bool condition 2 equals, let's make it equal to this condition here. Value is less than 10. Value 1 is less than 10. Is value 1 less than 10? Yes, it is. So this condition is going to be true. Let's output it and double check. So condition 2, we'll output that, and we find that it's true. Remember, 0 is equivalent to false, 1 is equivalent to true. So now we've got one condition that's false and one condition that's true. We can now, let's copy all this to save some typing. I'm going to call this condition 5, and we're going to get rid of this. We can replace all of this now with condition 1 or condition 2. And that's a lot simpler to work out because it goes step by step, and we see that this is going to be true. Condition 5 is true, because although this is false, this is true, and this is saying if either of these are true, if this is true or this is true, the whole condition is true. Let's format that, because we mustn't leave badly formatted code in there. For some reason my auto formatter, oh yeah, there we go, it wasn't working, but there we go, it's working now. So it's easy to read this, and now that we've checked these values as we develop the program, we can get rid of the couts, and it's easier to understand this than it is this, particularly because it kind of forces you to go step by step through it a little bit more, and you don't have to rely on understanding the order of the condition evaluation anymore. It's clear what's being done in what order, and it's easier to understand this. So that's it for this tutorial. It's worth trying this for yourself. If you want, you can type out this exact code, but it's even better if you declare some variables. You can also experiment with strings, which can be compared with equals equals and not equals, and try various combinations of conditions, as I have done in this program. Try the logical and the logical or. Try combining things and check that you get the results that you expect. And also try really complicated conditions. You can make them as long as you like, but try breaking them up. Try using the brackets, but also then try breaking them up using separate Boolean variables and then combining them to create a much simpler expression like this. So there's an art to doing this, to figuring out how to create conditions that are as simple as possible. And you have to strive to do that to try to make your code readable. But it's really worth trying this, and you'll find as you go along, or I find, that things don't work out as I expect just because I misread some little symbol or I forgot what the value of something was. It's really easy to do that. But by trying this out for yourself and experimenting with code and using all of these conditions, it really helps to get it into your head what each one does and how you kind of parse them mentally, how you break them down mentally to understand what's going on. So that's it for this time. By the way, just a quick mention. I originally created this tutorial and realized I'd made loads of mistakes, not in the code, but in reading out what I was actually writing, because I'm trying to write and talk about it at the same time. So I've recreated this tutorial now, and these workspaces here are actually from my advanced C++ tutorial, which it's now October 2014, and this is going to be available soon. So do look out for that if you manage to get through this tutorial. Okay, so until next time, happy coding.